Let's discuss another important topic in fluid mechanics, which is forces due to pressure. So let's discuss hydrostatic forces. Hydrostatic force on surfaces. This is an important topic because based on the water pressure or based on the fluid pressure, you should be able to find out what is the hydrostatic force. Okay, so before just going into what surfaces we will deal with, first let's define what we are going to calculate here. So we will study two things here. One is the total pressure, which is, even though the name is total pressure, but it is the force exerted by static mass of fluid on a surface. Now this surface can be plane or curved. Okay, and so this is the force exerted by static mass. So fluid is stationary. Let's say you have a dam or something, okay, and you have a stationary fluid. So the objective is, due to this stationary fluid, you have this pressure. So because of this pressure, if you integrate this pressure over the entire surface, you get force. That force is called as total pressure. So it's basically the force exerted by the static mass of fluid. And now, so there is another terminology which is used here, that is center of pressure. This center of pressure is basically the point of application of this total pressure. So if I replace this entire distributive, let's say this entire water pressure, the resultant of this, with some force F, which is nothing but the total resultant force of this distributive pressure system, then this F is basically the total pressure, and the where it acts, let's say it acts at X bar from the top edge, that X bar is the center of pressure. So point of application of the total pressure on the surface is known as center of pressure. So these are the two definitions which are normally used while calculating hydrostatic force. So we'll study three surfaces. One is on plane surface, okay, which can be horizontal and vertical, and then we'll study about the inclined plane surfaces, inclined plane, and then the curved surfaces, because sometimes the surfaces can be curved. So curved surfaces, especially the gates of the dams, they can be curved. So we'll study curved surfaces also. So we'll study basically these three surfaces on how to calculate the total pressure and the center of pressure. Okay, so let's start with horizontal plane surface. Horizontal plane surface. Okay, so let's now imagine that you have a water which is water surface, okay, and you have a surface, a horizontal surface. Basically in the front view you will see as a line only, but I am just drawing the top view here. So let's say the center, so this entire thing is at a height h. Okay, now, so what is the force, and the area of this plate is A, the throat area is A. So what is the force now due to the fluid pressure? Now you know that the water surface, you have only the atmospheric pressure acting. Now for here we neglect the atmospheric pressure in this chapter. We just calculate the force due to the gauge pressure. Okay, so now, so whatever the pressure distribution that is there on this surface, pressure will not vary on this surface because it's at the same height. Pressure doesn't vary on the surface on the horizontal surface as all the points are on the same height. Okay, and if I assume that here the gauge pressure is 0, so pressure on the surface will be, at any point on the surface will be pressure at the upper surface atmosphere plus rho gh. So this is basically how pressure varies with height. This we have seen in the previous section. So P atmosphere, we are assuming we want to calculate the gauge pressure, so I assume P atmosphere 0. So rho gh is the pressure that is acting on all the points. The force will be, as the pressure is uniform, we can just multiply pressure into area, and so area is this, the one which is exposed to the water, so rho gh into A. So this is basically the total pressure. This is quite simple, the total pressure, because the pressure is uniform, so it just turns out to be simple derivation. So total pressure is basically the force, hydrostatic force, which is rho gha, and obviously the center where it acts is, because it's a uniform distribution, the center of the center of pressure is basically the centroid of the area here. And if it's a rectangle, it is at the center. So this is about horizontal plane. So now let's see vertical plane. On the vertical plane surface, how it acts.